This video is going to focus on what solubility is. Solubility is a measurement of the maximum amount of solute that will dissolve in a given amount of solvent at a specific temperature. So solubility is temperature dependent. It's typically expressed in grams of solute per 100 grams of solvent. So when we say a solute dissolves in a liquid, we're saying it's soluble. When something does not dissolve in a liquid, it means that it's insoluble. There are certain factors that affect solubility. We've already discussed last video the nature of the solute in solvent, like dissolves like. Polar and ionic solutes will dissolve in polar solvents, and nonpolar solutes dissolve in nonpolar solvents. As far as temperature goes, we need to know that most solids are more soluble when the temperature goes up, but that gases are the opposite. So that's something that I would make note of, and we're going to see that in reference table G, that gases are going to show a different pattern within solubility. Gases, as the temperature goes up, become less soluble. So typically when you increase the temperature, we can get more solute to dissolve. Gases, when you increase the temperature, less will dissolve. And the last factor we want to talk about with solubility is pressure. Pressure has no effect on solids or liquids. If you increase the pressure, it does nothing to making it more soluble. However, with gases, if you increase the pressure, they become more soluble. And you can see this, for example, in soda. When you open up the cap of soda, you're taking or decreasing the pressure. The soda, you hear that the soda leaves the solution. It becomes less soluble. So with the cap on, with more pressure, the carbon dioxide gas stays dissolved better. So less pressure decreases the solubility. So here's a picture showing you this, that gases are kind of unique. So something to keep in mind, that they're more soluble with under high pressure. That's only for gases. Pressure has no effect on solids or liquids. And when the temperature is cold. So think about, you like soda cold because you have all those bubbles of carbon dioxide dissolved in it. We have a lot of vocabulary in this chapter. I apologize about that, but two more words we need to know are dilute and concentrated. Dilute means just a small amount of solute. So you could see the picture on the left-hand side. There's only a small amount of little red dots. Concentrated means a lot of solute per solvent ratio, so more red dots on the right-hand side to show a concentrated picture. So we have three different ways of describing solutions. We can call them saturated, supersaturated, or unsaturated. Saturated means it's containing the maximum amount that can be dissolved at a specific temperature. It's at equilibrium between the amount that can be dissolved is equal to the amount that will start to at some point come out of solution undissolved. So every time we see the word saturated, you want to think equilibrium. The rate of solute dissolving equals the rate that it will start to come out. So you may have seen that if you were making iced tea, you could stir and stir and stir and stir, and eventually there'll be some type of level of sugar sitting on the bottom. You can't get any more sugar to go into the water. As much as could go in is going to go in. So you could stir it, maybe you get new sugar pieces to go in, but then some are going to come back out, so you have a consistent amount concentration sitting on the bottom. So when you see the word equilibrium, think saturated, but saturated means that you have as much as you can get to go in as you're going to get. Unsaturated means it's holding less solute than it could hold at a given temperature. So that would be like if iced tea was really watery and you could add more sugar and it would dissolve in because it's not holding as much as it could hold. And supersaturated is a special type of situation that you probably really haven't seen in ordinary situations. Maybe something like rock candy is the best example for you, but it's holding more solute than it should be able to at that temperature. The way that they make these supersaturated solutions is by carefully cooling it down. They're very unstable. I'm going to show you an example of one in class. Sodium acetate, where we'll just add a little seed crystal and the whole solution will precipitate out. So very, very gentle. You got to deal with supersaturated solutions. And then lastly, solutions can exist in many different phases. We tend to think of solutions as only being solids dissolved in liquids, like salt water. Salt is a solid dissolved in a liquid water. But solution really could be any phase. You could have solid and liquid, you could have gas and liquid, gas and gas, liquid and liquid, solid and, there's no one specific way as long as it appears to be homogeneous. Okay, table G is going to show us the different solubility curves that we're going to be looking at. So if you could take a second, open up to the reference table G. It's going to show you curves for solids and a few gases that are dissolved in 100 grams of water over a temperature range of 0 to 100 degrees Celsius. So whatever they ask about solubility, we can come here to look it up. So let's look at how we read table G. If you are looking at any particular line and there's arrows that point to the line, if the point falls above the line, it's supersaturated. If the point falls exactly on the line, it's saturated. And if the point that we're looking at falls below the line, it's going to be unsaturated. So we're going to do lots of examples based on Table G tomorrow, but just to give you an idea, we have a star to show you when you're going to be supersaturated, saturated, or unsaturated. So if I was talking about NaNO3, I'm going to find the NaNO3 line. So here it says NaNO3. See how there's an arrow that points to it? So we're looking at this line right here. There's a blue star to show you that if I was at, let's say, 120 grams and 40 degrees Celsius, I'm above the line. So 40 degrees Celsius, 120 grams. This purple star is a supersaturated solution of NaNO3. When I'm exactly on the line, so 40 degrees Celsius, 105 grams, I'm saturated. And then if I had 90 grams of solution at 40 degrees Celsius, I'd be below the line, so I would be unsaturated. So tomorrow we'll go through more practice examples of supersaturated, saturated, unsaturated. But for now, we just want you to be able to find a point based on temperature and solubility and figure out if it's saturated, supersaturated, unsaturated.